Thank you all for being here today, everyone. And also thanks to Gitanjali, thanks to the UpGlo team for the opportunity. And just a note, the slides and the transcript for this talk will be available to you later, okay? So Gitanjali already did an amazing job of introducing me, and thank you for that, Gitanjali. I graduated in mathematics. I got my master's and PhD degrees in Brazil and worked as a researcher in Brazil and in Germany before coming to the US. And my native language is Portuguese, right? So continuing the ideas that we started in our last, let me, okay. Fix Zoom here. Okay, we're good. We started some ideas in our last tutorial, right? On the tools you use as a data scientist. And let's talk about Git today and their friends, right? So GitHub, Bitbucket, GitLab. But before we start seeing anything on what's Git, GitHub, and other things, let's see why Git exists to begin with, right? So we always have this question, what is Git? You know, Alex, you're talking a lot about what is Git. Why is it good? Why do I need to use it, right? So first, let's see, why was Git invented, right? Why does Git exist? Why was it invented? What kinds of issues does it solve? Let's start from the very beginning. So this is Linus Torvalds, the creator of Linux. So Linux is an operating system, more or less like Windows or Mac OS. The difference between these systems is that you can see the source code of Linux and even contribute to it. Linus made Linux available in 1991, and this is the email that started it all, right? So hello, everybody out there using Linux. So this was another system, and then Linus had this idea and started creating another system, and he asked people to actually be there and contribute to it, right? So then people started contributing to the base system, and now it's a huge project. Last year, it contained more than 27 million lines of code, written by more than 21,000 programmers. So how do that many people work in the same place without breaking anything? So in the beginning, the development of Linux was made this way. So Linus would put a package, a large compressed file containing all Linux code in a server. Then the contributors would download this file from the server and write their contributions in their own files, in their own computers. From these modified files, the contributors would create patches, smaller files containing the modifications from the original files they got from Linux. And these patches, these fixes, these corrections, these modifications would be emailed to Linus, who would download and check them. If these modifications were correct and did not break the system they had so far, Linus would add them to the original compressed file and upload this new version to the server. Then the cycle would continue with new modifications being emailed, checked, and added. Okay, this was the Linux kernel. This was the way the Linux kernel was built and maintained before, between 1991 and 2002. In 2002, the project started using a specific tool called BitKeeper. BitKeeper was a proprietary closed source project at the time, and at some point, the Linux community and the BitKeeper company didn't get along that well, prompting the development of a new tool to maintain the Linux code. And then Linus came to the rescue, and based on the lessons learned from BitKeeper, he wrote Git in 2005. If you'd like to know more about how Git was developed, there's this talk Linus gave to Google in 2007. Here he compares Git with other tools like CVS and Subversion and explains how Git is better than this. He gets very unfriendly at this talk, but it's interesting to understand the issues that the Linux community was dealing with at that time. All right, now we know some story on Git, some history on Git, and you can ask, Alex, you just told me about its origins, and since I don't work with thousands of people, you didn't convince me at all. Why should I use it? So I will describe two scenarios to show how Git can be useful for you. So let's suppose we are writing some code to solve a specific issue. We suffer a little bit, we have new files, we suffer a little bit, we delete some files, we try different solutions, we fix some bugs, we delete more files, we talk to people, we improve our code, test it, and reach a nice solution. Everything works as intended. Awesome. We close the file, we go home, sleep, come back to work. Then we check that code again and have an idea on how to improve it. Hey, let's try something nicer. Now we overwrite the existing code that was working properly, I remind you, and go on with our day. Then we notice that some file doesn't need to be there anymore because of our latest code. Now the code is improved, I don't need that file anymore. So we delete that file. Then we modify something else, and so on. Then some days later, we come back to test the latest code, and surprise, surprise, it doesn't work anymore. More than that, we don't have the version that was working properly. So we don't remember what we did in the first place or what files we deleted. What happens in these cases? We will have to rewrite our code all over again, and we don't have any idea on where to start. Now, after deleting things and losing code by accident a few times, we start duplicating the files before editing them, right? Then at some points, we will have several different versions of the same file within a folder. Like this, where you don't know you don't know that much when we can delete a specific file because we are afraid of losing something. I still do it. In this right window here, you can see like these three selected files are the same text with some minor modifications. So, but these three selected files have basically the same text, right? When we use Git, it shows exactly what modifications it did to a file, line, everything. You see here, for example, that I deleted the code in red and on the left and added the code in green on the right. If I wanted the code back, I could use a command on Git and it would make the necessary replacements. More than that, Git maintains a history of each file in a repository. Using Git, you won't lose any more code, and you can even delete files. If you want them back, they can be recovered. Now, the other scenario. You have another person or persons working with you on the same project. There are other ways of doing this, such as a Google Drive or Dropbox or a shared folder on your network, for example. Then, let's suppose that you and Chandler open the same file at the same time. Now, you edited the file, added all that sweet, nice code, and saved it first. Remember? Chandler was there, and he didn't know you were working on that file. He comes, writes his own code, and saves on top of your work. There you go. You just lost all your code on that file. All your work, it's gone. When two people using Git edit the same file at the same time, Git says that there's a conflict. It's nothing too serious. It's only Git saying, hey, I have two different changes coming on the same line. Which one should I keep? In this case, if Bob saves the file after Alice, He solves the conflict, deleting the lines that are being replaced, and then neither of them loses their work. Okay? All right, I hope that these scenarios convinced you of why using Git will be great for you and save you a lot of work. Now, suppose you want to store your code on the internet while retaining Git capabilities. So people can suggest changes in your code and you can track modifications on the latest versions. This is where GitHub and its friends come in. So GitHub, GitLab, Bitbucket, they are different services to do the same thing. They host your Git repository on the internet. These platforms are used when you want to work with other people on the internet or when you want to make your own work public, to share your code with other people. And you can think of them like fancy Google Drives that you can use with Git commands, restore files, and so on. On top of Git capabilities, they have different options. For example, you can track issues on your code. You can configure automatic actions and more. Their pages don't look alike, and things can be in different places in these platforms, but they work the same way in what matters to us. So if you know Git, you're capable of using any of these platforms. Okay? So let's concentrate on GitHub today. This is GitHub main page, which appears when you type github.com in your browser. I mean, this is the page today. They change it once in a while, right? So to open an account on GitHub, type your email address at this box where the hand shows it, and click the green button. Then you will fill your desired username, email address, and password. When everything is okay, you'll see these green ticks on the box. At the end of this page, you answer that nice Galaxy CAPTCHA to verify that you're a human. Then you click the large blue button to create your account. You'll receive an email confirmation, then you're good to go. So this is my main GitHub page. This is my profile, if I'm correct. You have one more or less like that. I do lots of my work on Git, so you're seeing several activity in there, but you get there. Okay. Here you will see your username, activity indicators from you and from people you follow. Yeah, you can follow people on GitHub. And your repositories as well. You can create a new repository from this page, clicking the green button there. And don't worry about that right now. We will see more of that in a few. Okay? All right. So far, we saw a little bit of a history of Git and why we use services like GitHub, GitLab, and Bitbucket. Now, to understand what you usually do when working with Git, let's walk through a basic example showing the Git workflow. So this is more or less how you will work with Git most of the time. You will create a repository, copy it to your machine, create a branch, add your files or changes to specific files to that branch, commit and push the changes, open a pull request, merge it if you have the necessary rights, and pull the changes back to your machine, and all over again. It seems like a lot, but don't worry. Instead of only telling you these steps and leave you with lots of words, let's see an example on how these steps are made, and then you get a better idea on what these concepts are, okay? Just a fair warning, I will interact with Git and GitHub through the command line using a Linux terminal. The commands are the same, independent of the system you're using, like Linux, Mac, Windows. Git is the same to all of them. And please don't worry about memorizing anything I will show you now. It's just to give you an idea about how the process goes. And also, there are a lot of concepts involved. So don't be afraid if you don't understand everything that you see here. You understand these concepts more when you start working with them, making errors, fixing those errors, and so on. So first step, you will create a repository on GitHub, right? Okay, you opened your account on GitHub, and now you have this profile page. To create a new repository, click on the green button on the top left. This one at the right, the hand is showing you. Then you will have a couple of questions on this page. The important one for us now is the name of your repository, which I will call upglo-git-webinar-2021 in this example. You can also enter a description of what this repository is about, but it's optional. Then you will choose if this repository is public or private. GitHub has some restrictions on private repositories if you're using a free account. Mainly, you're limited to 3 contributors. I will keep it public in this example so everyone can see it and contribute to it as well. Here I check the add a README file box, and this way GitHub will create a readme.md file, and we can start working on that repository immediately. When GitHub creates this repository, this README file will contain the name of the repository in it. So to finish creating a repository, click on the green button labeled Create Repository on the bottom. Now, you can work in this repository directly on GitHub, but most of the time you will want your work on your own PC where your software is installed. So GitHub doesn't have, for example, a Python installation you can use, an R installation. So this way, it's better to clone this repository in your own PC. Then you can use your own tools and send the changes back to GitHub when you're finishing it. Think about cloning a repository like having a copy with steroids. When you clone a repository, you will have all history of that repository on your PC. And you can come back in time to any modification made using Git. Even if you didn't create that repository, this works with every repository on GitHub. Okay, going back to GitHub, in your repository page, you will see a screen like that. To clone the repository in your machine, push the green button labeled Code. When you click that button, you will receive this window with the address where your repository lives in different protocols, HTTPS, SSH, and so on. You can choose yours here and click the gray button, the copy button on the right side to copy the address. Or you can click on download zip and it will download a zip file with the repository in it for you. They work the same. In this example, I will use SSH, one of the protocols given as an option there. I copy that address and using the terminal, I go to the folder I want on my PC. So you see that the folder here for me is docs-bids-UpGlo. Then I type git clone and the address I copied on the previous step. When I hit enter, Git copies the repository on GitHub into my PC. So it shows this nice information like cloning into this folder, UpGlo Git Webinar 2021, and then receiving objects 100% done. Okay, so if you're in doubt or you don't have SSH installed in your PC, try HTTPS as the first option. It should be the easiest way. And again, if you don't understand anything what I'm telling you, you can click on download zip on the last step, download the zip file, and unzip it wherever you'd like on your PC. It works the same way. So on the bottom left, you see the folder on your repository. Here you see the small folder like Alex, Docs, BIDS, UpGlo, Git Webinar 2021. which contains the README file we asked GitHub to create. On the bottom right, I opened the file. So you can see that it contains the text that GitHub put there before, the name of this repo. So I can say repo and repository. Repo is the cool name the kids are doing, the kids are giving. So repo and repository are meant to be the same, okay? So now we can start working on the repository. But first, it's good practice to create a branch. Branches are places on Git where you can play and modify code without breaking anything. When you finish working on a branch and everything works nicely, you can ask to add the changes to the main code. So let me give you an example of how branches work before entering there. Here, suppose that the main branch has the original work. Here is shown in blue, and it has a shoe and an apple. On the second step, we create a new branch called add dog, which will be seen in red. And we will add our work in there, a dog, right? On the third step, we create a branch called remove shoe. There we add our work. So this remove shoe branch is seen in green in this image. And there we add our work as in removing the shoe, right? Meanwhile, the dog is being committed to the add dog branch. On the fourth step, add dog is merged to the main branch. Now, the main branch has shoe, apple, and dog. Meanwhile, the shoe is being removed on remove shoe, and this change is being committed on the remove shoe branch. This change is merged to the main branch on the fifth step, where we end with apple and dog only. Of course, I'm taking several freedoms here, but just to give you an idea of how branches behave on Git, how you will use Git's branches, okay? Now, let's create a new branch on that repository. To do that, I use the command git checkout-b and then the name of the branch. Here I'll call it my awesome branch, but it can receive the name you'd like. The argument -b here says that Git needs to create a new branch, that this branch, my awesome branch, doesn't exist. It's a good practice to name branches with what you will work on in that specific branch. So my awesome branch doesn't help us at all here. So, for example, fix window bug, when that branch will be used to fix a bug on a specific window, or add country data, when you're adding data on a country to that repository. After creating that branch, we will go to that folder and open the README file. Then I'm adding a little bit of text in that file, making some changes. So you can see the changes I'm adding here on the bottom right. Okay. After saving that file, I can use the command git status on that repository. So it will show me the files that I modified, but are not in the staging area. I'll get to that in a bit. The font is not helping too much here on the terminal, but in this case, the text is red and the line there reads modified readme.md. Then we can use the command git diff readme.md, and Git will show us the differences between the original file from the main branch and the file on my awesome branch. Deleted lines appear in red and added lines appear in green. If there are lots of changes, you can use the arrows on your keyboard to go up and down them. After checking the changes on git diff, you can press the Q key to come back to the terminal. Okay, after checking our changes, and being happy with them, we can use the command git add with the name of the file we want to add. That tells Git that this file is ready to go to the staging area. We can use git status again to confirm that everything is okay. And now we see that the line saying that the README file was modified appears in green. And Git says changes to be committed. Now we are ready to commit. A commit is a snapshot of the last staged changes. In this example, when we commit, Git will set a checkpoint with our changes to README, storing our changes to the repository. To commit, we use the command git commit, and we can add -m to name our commit. This way we can remember what modifications are being made in that specific commit. In this case, the commit is called adding info to the webinar. So it's adding info on the webinar, yes. So notice that when we commit, the changes will stay in our local repository on our PC. To send them to GitHub, we will use the command git push. Here we also included the name of the repository that's receiving the changes. In our case, it's origin, which in this case is an alias on our PC for the branch called main on GitHub repository. And the name of the branch we are adding, in this case, my awesome branch. Now Git finishes adding this branch and shows an address saying, create a pull request by visiting such and such. That's our next step. But before, let's talk about the Git staging area that I didn't talk about before. When you add files to Git, using git add, they are not added to the repository immediately. You can add and remove files as much as you want, and your changes go to an intermediate place called the staging area. They are added to the repository only when you use the command git commit. Okay? Now, we will come back to GitHub and open a pull request. We can use the address that Git gave on the terminal before, or you can go directly on the repository on GitHub. So when we get there, we see that GitHub already shows us the changes it received, and it offers a button labeled Compare and Pull Request. When you click on it, you start your PR. So again, I'm saying PR and pull request, they're the same. I'm sorry about that. You get used to it. You see a lot of that. Now, we will come back. And when we get there, we see that GitHub already shows us the changes it received, right? And it shows the page now, open a pull request. There you can add a title for your PR, comments, and other changes as well. As with the commits, it's a good practice to add names that are relevant to the issues you are solving or to the functionality you're adding, okay? You can also see your changes again in a nicer way than in the terminal. When you're happy, push the green button labeled Create a Pull Request, okay? And that's it. We got ourselves a PR. Now GitHub will show it to the people on the repository and they can take action on it. When the repository is yours, or if you have the necessary permissions, the green button Merge Pull Request will be available to you. Then you can merge the new modifications in your code if they're okay. So this is how GitHub shows a merged PR. Everything that was green is purple now, and there's nothing much to do. It stays in the repository history, excuse me, And if you'd like to revert these changes, you can. Okay. Now you did all of it. You created a branch, modified it, committed the changes, pushed them to the main branch. So when these changes are accepted, you need to pull them back on your machine. Let's do it now. All right, again in our terminal, we can see git checkout again to come back to the main branch. And we don't need the -b option here since the branch called main already exists. After that, we use the command git pull with the name of the branch that has the changes and the branch that will receive them. We want to get the changes from origin, again, an alias on your PC for the branch called main on the GitHub repository, and put them in the branch main in your PC. So we use push to send changes and pull to receive them. Then Git shows what files were changed and how much. As in, you will see how many line insertions and deletions in each file. All right, that's a basic workflow on Git using GitHub. And again, don't worry too much if you didn't understand most of it. I just wanted to give you an idea on how the work is done from the internet to your PC and show some of the concepts involved. From here, you can check the courses you have access to. Ceci will have more information about that after the webinar. And since we broke the ice already, I hope you will have a better understanding of the material check later. Also, this is a boring example. There's only one file with only one contributor. It gets really fun and useful when you're interacting with lots of people in one project. All right, so far we discussed the basic Git workflow using the command line and what services like GitHub and others offer for us. However, maybe I scared you a little bit with lots of comments in your first exposure to Git. When starting your journey, maybe you may feel some discomfort using Git comments and checking results in text on a Linux or a macOS terminal or on a Windows PowerShell. There are alternatives to the command line though. You could use a dedicated software, or possibly your code editor has some Git tools already available for you. Let's see some of these tools. The first software we see today is GitHub Desktop. It is very simple, but it has what's necessary to work using GitHub without messing with the command line. You can work with different branches, check the differences between your latest code and the current files, and so on. If you install GitHub Desktop, you don't even need to install Git. It has it embedded already. If you don't have any idea on how to use a terminal and you're using Windows or Mac because they don't have a Linux version yet, I'd recommend trying it on the beginning, in the beginning, and checking its documentation. You will have a nice idea on how the concepts we discussed today will appear on a GitHub repository. Now, to the code editors. The one I use most these days is VS Code, Visual Studio Code. It has a great interaction with Git and GitHub. You can see and commit your changes, create and merge different branches, everything without leaving the editor. For example, this is one of the representations that VS Code presents for our example. You can see the branches, like the small lines, and you only need to use the plugins that are already available for VS Code. You don't need anything else. I personally don't use Git on the terminal on the command line that much these days. I prefer using the options here on VS Code. If you'd like to know more about how to use VS Code with Git and GitHub, I recommend to you these two small pages. Check them whenever you'd like and try to reproduce the examples they provide there on your own PC. Checking these, the one about Git first, and then the one about on GitHub, you will have a general idea on how to use these in your daily activities. Okay? And there are way more examples on Git within different code editors. If you use a recent code editor, it's very likely that it has support to Git already. So you may check the documentation page for your favorite editor, okay? Well, we are reaching the end of this webinar. So before we finish though, today I'll give you some homework. I'd like you to open your GitHub account if you don't have one already. Then please clone this repository made specific for the webinar. And don't worry about copying the address. You will have these LEDs after the talk, okay? And these links are all clickable. After cloning the repository, using the tools you'd prefer, create your own branch to receive your modifications. Then add a new line with some text to the file we use today, readme.md. Write your name, write hello world, whatever you'd like. But please keep it family friendly though, okay? So at the end, please commit your changes and I personally will check your modifications. Just a reminder again, use the tools you prefer. Please don't feel restricted to the ones I presented today and don't feel pressured to use the command line, for example. Use whatever tool or method suits you the best. Okay? Now, let's keep the tradition of telling you some stories, okay? On one of my first days here at Berkeley, I accidentally broke Scikit image, one of the projects I work on here. You can see that I deleted around 2,000 lines of code here, right? Yeah, I pushed some wrong code to the main branch and it would spoil every code that came after that. So I didn't know that much about Git at that time, and I still don't understand that much, to be honest. So I asked for help from two friends of mine, Nel Varuqua and Sebastian Berg. And they explained me what happened and what I should do to solve it. In that case, reverting the modifications to a specific commit back in time, when I knew things were okay, did the trick. Now, there are two lessons to learn from this story. One is that everything that has been committed in Git, and therefore GitHub, GitLab, and so on, is reversible, okay? So don't worry when something goes wrong. It can be fixed. Commit often so you can get back to the point you want when needed. The other lesson is that having good friends is great. Never underestimate a good friend willing to help you with your work. In some cases, they can save your job, as they did to mine. Example of good Git friends these days are the Git documentation, a good book, Stack Overflow, searching on the internet. When you're having an issue, try to Google, Bing, DuckDuckGo it on the internet. I'm pretty sure someone already went through that issue, and the answer you're looking for is on the internet already. And here at the end, I listed several resources I use for this talk, and please check them to learn more about Git and GitHub. We also try to add some books and some courses, okay? And that's it for today. As I said in the beginning, the slides and the transcript of this talk will be available for you later. And thank you again for being here.